Hello everyone, hope you are doing good. Welcome to the post discussion for the biweekly contest 100. I hope you have tried this contest. I felt like it's on the easier side, except the question one. If you attend, you will surely know why I'm speaking that, right? Today we will try to discuss this particular question: how to mark all the elements of a given array and find its score. Right now, coming to the question here, yeah. Yeah, we are given array nums. Let me see what are the constraints for nums. Okay, again it is 10 power 5, right? Whenever it's 10 power 5, we need to find optimized solution. We can't go with brute force approach, right? Most of the cases. Consistent of positive integers, right? They are saying something is a score which is of 0, apply the following algorithm. Starting with score 0, apply the following algorithm. Choose the smallest integer of the array that is not marked. There's something called marking, which they're talking about, right? If there is a tie, choose the one which is the smallest index, right? So the marking is based on the value of the integer. We have to choose the smallest value integer first before the value which is bigger than that, right? Before integer which is bigger than that. Always choose the smallest value integer. If there is a tie, choose the one which is having the smallest index, right? Add the value of the chosen integer to the score. So score will be score will be the value, score, which is score is equal to score plus the value of the smallest integer at that moment, which is not marked, right? Mark the chosen element and its Trojan value if they exist. Repeat until all the elements are marked. So let me quickly give you example of this thing. See, this is the one, right? We can clearly see that one is the smallest element, right? So when I choose one and add it to my score, right? Let here is the one. I'm choosing and adding to my score. Now, what are elements should be marked? The element to the right of it and the element to the left of it. So together we are marking these three elements. Marking means we will not visit them again, right? Remove these elements. What are the elements left? 4, 5, and 2. Which is the smallest now? 2 is the smallest, right? Take the element 2 and add it to the score, right? Here we are doing that. Take the element 2 and add it to the score. Mark the element right and left of it. There's nothing in the right of 2, right? There's nothing in the right of 2, but there's something in the left of 2. Mark it. Marking means we will not visit it again. So what are the elements currently marked? 2 and 5 are marked. 3, 1 and 2 are marked, right? The only one element which is remaining now is 4. Take 4, add it to the score which we are doing here. Mark the element to the left of right of it. If they are unmarked, see, this is already marked here. So we can't do anything now. And we are done. We have like marked all the elements now. So what is the score? 1 plus 2 plus 4, which is 7. The same case they are doing it here. First we are taking 1. We are marking these 3 elements, right? It's being done. Then there are two values of 2, right? This is also 2. This is also 2. But we have to take the one with the lowest index, right? Take these 2 and mark these 2 elements. So we are taking this 2 here. So what are the elements currently marked? These 2 are marked and these 3 are marked because of 1. So only remaining is 2, right? We have done that as well. So finally the score is 5. Now how to solve this question? I hope you have understood the question. Please rewind the video and check for yourself if you have not understood. Examples are actually self-explanatory, right? So yeah, the solution is now I am taking a value n, which is the length of the array. I'm initializing the answer here. I am creating an array. I will quickly show you how it is. In array, what I'm doing is I will have two values for each of the elements of the nums, right? First one will be the value of the nums itself for the ith index, and then the value of index itself, right? How it looks, let me quickly show you. See here, so this is how it looks. So the number of elements here and the number of elements here will be same. But for each element of here, for example, 1 is the smallest element, I will capture 1 and its index. 2 is the smallest element, 2 is the second smallest element, I will capture 2 and its index, right? Similarly, this 2 is the next smallest, I will capture this 2 and its index. Similarly, for each element, I will capture that element and its index. Then I will be sorting them out. This is how it's being sorted, right? After making this array, so what is this array? For I'm going to each element of the nums of I. I'm capturing that as well as I'm capturing its index because we need index in this question. Now in the question they have clearly mentioned this that if there is a tie, right? If there is a tie, it chooses the index with the smallest index. That's why we need to capture index as well, right? Not just the value. Now I'm sorting it. How I'm sorting it? I am sorting it first based on its value, right? What is x of 0? X of 0 is its value, and then based on its index. This is what they are mentioning there. If there is a tie, we have to take the smallest of them, right? And I'm printing it. Then I'm declaring a set which will be storing the indices which are already visited. Visited means marked. We can also call it marked index, right? I am calling them. I'm using the term visited. You can also call them marked, right? Now I'm going through the array A. I will be the value which is here, nums of I, and J will be the index. Okay, J will be the index here, right? Now, if J is in visited, that means J is already visited. Continue. That means do not execute this particular part of the loop. Directly go to the next element. Okay, it will be continuing. It will not execute this part. I will come to this part only if my visited that J is not in the visited index set. Right? If it is so, add it to the visited index set. Now I will increment the corresponding value to answer. Right? Answer is equal to answer plus I. Now we have included this j. Now we need to mark j minus 1 and j plus 1 as well, as we saw here, right? We have to mark the elements which are adjacent to it, adjacent elements as well. So if j minus 1 is greater than or equal to 0, in that case, add it in the visited index set. If j plus 1 is less than or equal to n minus 1, add it in the set, right? This we need to do for each and every element of A. See, the trick here lies only in this part, how it is being done, these two part. If you understand these two part, the whole question will be clear to you. They are clearly mentioning we need to sort based on value first, and if there are two values which are same, then we need to sort it based on the index. That's why I'm capturing index as well. So this is how the sorting is being done, the criteria for sorting. First based on the value and next based on the index, right? And finally we are returning the answer. I will quickly run and show you how it is being done. So yeah, you can clearly see the outputs are matching. The expected output and the output from our code are matching, right? I've also captured how this program performs. You can clearly see it being 75% of the solution. If you have any doubts, please comment it below. I would really like to discuss them. And if you like my video, if you like my content, please like and subscribe. That's all for this video. Thank you.